Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the last few videos I have told you about nonlinear applications of OPAMP. In this video what we'll do is we'll take a look at some of the problems that are based on nonlinear application, and we'll understand how to tackle such kind of problem. See, in this problem it is saying find V0 when Vin is positive and Vin is negative. You have to assume that the cut-in voltage of diode is 0.7 volt. Now what I have told you about diode circuits, you apply open circuit test. Okay, just observe this OPAMP like this much. If you open circuit both the diodes, that is we are applying open circuit test. In that case, there is no closed path for current flow. That is, it is open loop configuration. If it is open loop configuration, then it is working as an comparator. In that case, see, we have to compare the positive and the negative terminal voltage. If Vin is greater than 0, in that case, the positive terminal voltage is greater than 0, or you will say VA is Vsat. If VA is Vsat, D2 will become forward bias. Why it is becoming forward bias? Because anode is connected to positive voltage. But for D1 the cathode is connected to positive voltage. So D1 is reverse bias. Okay. In that case, what I will do is I will redraw this circuit. Vn this diode forward bias will be replaced by a battery. Okay. Minus plus. Okay. Then there will be a 1 kilo ohm resistor. Then 2 kilo ohm resistor. Now the other path is open circuited. This voltage is V0. The current here is 0 ampere. If the current here is 0 ampere, the current I, this will also be equal to I. Due to negative feedback, I can apply virtual ground. The voltage here is Vin. So what is the current here? Since the current here is 0, this current is also I. So I can write I as simply Vin over 2K. The voltage here is Vin. The voltage here is V0. I can also be written as V0 minus Vin by 1.5K. These 1K and 0.5K are in series. Why they are in series? Because the current through them is same. So K gets cancelled. 1.5 Vin is 2 V0 minus 2 Vin. So V0 is 1.75 Vin. Okay. Now see the opposite case. When Vin is less than 0. If you are applying negative voltage here, then positive terminal voltage is less than negative terminal voltage, VA will be minus VSAT. If it is minus VSAT, the anode of D2 is connected to negative voltage and cathode of D1 is connected to negative. If anode of D2 is negative, it will be reverse bias, and cathode of D1 is negative, it will be forward bias. If D2 is reverse bias, it will be open circuited like this, and this will be replaced by a battery 0.7. Now what you can say is, again you can apply virtual ground due to negative feedback. If I can apply virtual ground, the voltage here will be Vin and the current will again be Vin by 2K. Okay, and the voltage here is V0. If the voltage here is V0, what you can say? What we can say is, if I apply KVL here, the current here is 0. So this voltage is 0 volt. By virtual ground, this voltage is also 0 volt. So I will say, suppose this is I1, this is I1. I1 is V0 minus 0 by 0.5K. Are you getting my point? The current here is 0 ampere. So the voltage of positive terminal is 0. If voltage of positive terminal is 0, the voltage of negative terminal is also 0 by virtual ground. So what is this current I1? V0 minus 0 by 0.5K. What about this current I1? It is 0 minus Vin by 1K. So V0 is minus Vin by 2. Okay. So that is when Vin is negative, and this relation is when Vin is positive. Okay. So that is how we can derive the output of this rectifier. It is actually nothing but a full wave rectifier. Next problem. It is asking us to sketch the output V0 for sinusoidal input. Vin is given as 5 sin omega t and cut in voltage is 0.7. So let us start this problem. See, the voltage here is reference voltage 2 volt. So this voltage will be fed back here. So suppose diode is open. I am applying open circuit test. So what is V0? V0 is V reference equal to 2 volt. In that case, the negative terminal voltage is also 2 volt and positive terminal voltage is Vin. This is suppose Va. So let us take two cases. Vin is greater than 2 volt. In that case, positive terminal voltage is more than negative terminal voltage. Va will be Vsat. If positive terminal voltage is higher, Va is Vsat. This is the cathode terminal. If cathode terminal is connected to positive voltage, in that case diode is reverse bias. So that means our hypothesis is correct. So when Vin is greater than 2 volt, V0 will be 2 volt. Now when Vin is less than 2 volt, if Vin is less than 2 volt, in that case positive terminal voltage is less than negative. If positive is less than negative, Va is minus Vsat. If Va is minus Vsat, cathode is connected to negative voltage, the diode is forward bias. If this diode is forward bias, then what you will do? You will replace this diode by a battery. This battery will be 0.7 volt. Due to this, negative feedback path is completed. Negative feedback path is completed. You can apply virtual ground. If you can apply virtual ground, you will say negative terminal voltage is same as positive terminal voltage is equal to Vin. So this voltage will be Vin. due to which if you see it is directly connected to V naught, V naught will also be V in. That means if V in is less than 2 volt, V naught is V in. If it is greater than 2 volt, it is equal to 2 volt. So let me show you how to draw the output. So suppose V in is a sinusoidal wave of 5 volt amplitude. Okay. Now I will draw a line of 2 volt, that is the reference voltage. So what we are saying, if V in is less than 2 volt, then V naught is V in. So at less than 2 volt you are at V in. Output follows the input. But at greater than 2 volt, output is 2 volt. Like this. So what it is working as? It is working as a positive clipper. That means I have realized the clipper circuit with the help of OPAMP and a diode. It is working as a positive clipper. Next, sketch the output voltage for triangular input of peak voltage plus minus 10. Again the cut-in voltage is 0.7. Okay. Now first what I will do is, I will apply open circuit test. Whenever diode and OPAMP is given, you always apply open circuit test. This is minus 5 volt. R V in. This diode is open. This diode is also open. 2R and this is V naught basically. Now see, this voltage is suppose VA. There is no feedback path between the output and the negative terminal of OPAMP. No feedback. If there is no feedback, it is basically open loop configuration. If it is open loop configuration, it will work as comparator. You can see here, if there is 0 ampere current, the voltage drop across R will be 0. The voltage of this terminal will be V in. So you will say negative terminal voltage is V in, positive terminal is minus 5 volt. So if V in is greater than minus 5 volt, that is negative terminal voltage is higher. If negative terminal voltage is higher, VA is minus Vset. If this voltage is negative, the cathode of D1 is negative, anode of D2 is negative. If cathode is negative, D1 is forward bias, anode is negative, D2 is reverse bias. So if V in is greater than minus 5, D1 is forward and D2 is reverse. If V in is less than minus 5, okay, that means negative terminal voltage is less than positive. VA is Vsat. If VA is Vsat, cathode is connected to positive. Here anode is connected to positive. So D1 is reverse bias and D2 is forward bias. So we have found out the state of the diode in both the cases when V in is greater than minus 5 and V in is less than minus 5. Now we have to understand the output in each of the cases. Suppose V in is greater than minus 5. Then if V in is greater than minus 5, we are saying D1 is forward. If D1 is forward, it is 0.7. D2 is reversed, it is open. This is 2R, this is V naught. V in R. Now due to negative feedback, this is the negative feedback. Due to negative feedback, we can apply virtual ground. If you can apply virtual ground, you will say this voltage is minus 5. But no current can flow in this resistance. Why? Because there is no closed loop for the flow of current. So current here is 0 ampere. So if current here is 0 ampere, by negative feedback the voltage here is minus 5 and there is no drop in 2R. Why there is no drop? Because the current in 2R is 0. So V0 will be minus 5 volt. Are you getting my point? So what I am saying, if Vin is greater than minus 5, V0 is coming out to be minus 5 volt. Now let us take another case in which Vin is less than minus 5. So D1 is reverse bias, but this D2 is forward bias. If D2 is forward bias, it will replace by a battery of 0.7. Now see this, it is a complete feedback path. So we will again apply virtual ground. So this voltage is minus 5. What is this current I? I will be, let me delete this. Now V0 is not minus 5. I will be Vin minus 5 by R, or you can say Vin plus 5 by R. This I current will go here. So there will be a plus minus polarity across 2R. What you will say? V0 is minus 5 minus I into 2R. That is minus 5. I into 2R will be 2 Vin plus 10. So that is minus 2 Vin minus 15. So in this case, when Vin is less than minus 5, when Vin is less than minus 5, V0 is minus 2 Vin minus 15. So let us draw the output waveform. I will draw on the same curve on which I have given you Vin. See, why I will draw a level minus 5. When Vin is greater than minus 5, the output will be minus 5. Okay. When Vin is greater than minus 5, the output will be minus 5. So when Vin is greater than minus 5, the output will be minus 5. But when it is less, then output is minus 2 Vin minus 15. So when Vin is equal to minus 5, what is V0? Minus 2 into minus 5 minus 15, that is minus 5. But due to this minus 2, suppose when it is minus 10, at this point if I want to find, what is V0? Minus 2 into minus 10 minus 15, that is plus 5. So it will be like this. It will go till plus 5. Okay. Why it is coming upwards? Due to minus Vin. If minus Vin is this triangle, then if Vin is a negative triangle, then minus Vin will be a positive triangle. Okay. So that will be the shape of the output waveform. Next question. IS, that is the reverse saturation current, 10 to the power minus 13 ampere, VT 25 millivolt, eta equal to 1, Vin is 0.68 volt. We need to find the value of V0. What is this amplifier? This is anti-log amplifier. So I told you, due to this negative feedback, we will apply the concept of virtual ground. In that case, I will say negative terminal voltage is same as positive, it is 0 volt. So what I will do, I will apply KVL, Vin minus Vd equal to 0. So Vd equal to Vin, which is 0.68. So what about diode current? the diode current is approximately Is e to the power Vd by eta Vt. This diode current will go here. So I'll say 0 minus V0 by 100 ohm is Id. So V0 is minus 100 Id or minus 100 into Is e to the power Vd by eta Vt. So minus 100 into Is is 10 to the power minus 13. Vd is 0.68 by eta is 1. Vt is 25 millivolt, 0.025. So it will come out to be minus 6.5 volt. Okay. It is simple anti-log amplifier, but you don't have to memorize the relation. Just apply the concept of virtual ground and diode current relation and you can find out the value of output voltage. Okay. This much is fine. So let us move on to the next problem. Next question. Neatly sketch and label the DC transfer characteristic V0 versus Vin of the circuit shown in the figure. Vin varies from minus 2 volt to plus 2 volt. OPAMP is ideal and diode have forward voltage of 0.6 and 0 incremental resistance. So what does it mean, 0 incremental resistance? It means the diode resistance is 0. So when the diode is on, you will just replace the diode by a voltage source. That is, you will replace the diode by a battery. You will not show any resistance in a diode. Is it fine? So let us see. If you see here, there are two sources, Vin and Vref. There are two sources. So instead of dealing with two sources, what I do, I apply a Thevenin equivalent. So I'll draw this much circuit, I'll remove rest of the circuit. This is Vin R, V reference R. I want to know the Thevenin voltage and Thevenin resistance. So how to find Thevenin voltage? I'll say current I is flowing in this loop. What is this I? Vin minus V reference. What is the total resistance? 2R. Now if you want to find VTH, what you will say? VTH is Vin minus IR. That is the drop across this resistance R. Vin minus V reference by 2. That is Vin plus V reference by 2. That is VTH. What about RTH? For RTH, we will short circuit or ground the sources. If you ground both the sources, these two resistances are in parallel. So you can say RTH is simply R by 2. Okay. That will be the value of RTH. So let me draw the equivalent circuit in the next slide. We have VTH. Then we have RTH. It is connected to negative terminal of the OPAMP. What about positive terminal? Positive terminal is grounded. Okay. And with the negative terminal, we have a diode like this. Okay. Then we have another diode. And we have a resistance. Now what I have told you about the circuits containing diode and OPAMP, we will apply open circuit test. In that case, what I'll do is, I'll open circuit the diodes. Like this. This is your VD1, okay, and this is your VD2. Now due to open circuit, what you can say? There is no feedback. there is no path that goes from output to the input. That is, it becomes open loop configuration. If it is an open loop configuration, you can say that this circuit will work as comparator, in which the negative terminal voltage is VTH and positive terminal voltage is 0. If VTH is greater than 0, that is negative terminal voltage is higher, then V0. V0 will be minus Vsat. If V0 is minus Vsat, the negative terminal is connected to negative voltage, positive is connected to negative voltage. So D1 will be forward bias, or you can say if cathode is connected to negative voltage, diode will be forward bias, and if anode is connected to negative voltage, diode will be reverse bias. What if VTH is less than 0? If negative terminal voltage is less than positive terminal voltage, V0 will be plus Vsat. If you connect cathode to the positive voltage, the diode is reverse bias. If you connect anode to positive voltage, diode will be forward bias. So let me take the first case. If D1 is forward bias and D2 is reverse bias. Okay. If D1 is forward bias, you will replace it by a battery of 0.6 volt. You can say by virtual ground the voltage here is 0 volt. So what is V0? Minus 0.6 volt. So you will say when VTH is positive, V0 is minus 0.6 volt. Okay. That was given forward voltage 0.6. Now in the second case, when you will say that D1 is reverse bias but D2 is forward, so you will replace D2 by a battery. This is your negative feedback path. So what you can say, you can apply virtual ground 0 volt. So what is the current I? I will be VTH by RTH. This current I will go here. So what is V0? 0 minus IR plus 0.6. So I is VTH over RTH into R plus 0.6. What was VTH? It was minus Vin plus 1 by 2. RTH was R by 2 into R plus 0.6. So this R will get cancelled. So minus Vin plus 1 plus 0.6. So that is minus Vin minus 0.4. Okay. So that is how you can apply the concept that when VTH is less than 0, V0 is minus Vin minus 0.4. Now we have obtained both the values. Okay. Just let me check the value of VTH. VTH was Vin plus V reference by 2. V reference was 1. So Vin plus 1 by 2. That is what I have substituted here. So once we have obtained this data, what I am saying is, if VTH is greater than 0, that is Vin plus 1 by 2 is greater than 0, or you can say Vin is greater than minus 1, then V0 is minus 0.6. When VTH is less than 0 or Vin is less than minus 1, V0 is minus Vin minus 0.4. Okay. So now how you will draw the characteristics of input versus output, output versus input. Okay. So let us see how we will draw it. This is V0 and Vin. when V in is greater than -1, so the threshold is at -1. When V in is greater than -1, the output is minus V in minus 0.4. So at -1, how much it will become? 0.6. But it should be minus 0.6 actually. So let me check this case again. I is VTH over RTH and V0 is 0 minus IR plus 0.6. So minus V in plus 1 by 2 divided over R by 2 into R plus 0.6. So this will get cancelled, 2 will get cancelled. So minus V in minus 0.4. Okay. And when this diode was forward bias, this diode orientation is like this only, na? Okay. When this was forward bias, the output will be 0 minus 0.6. So minus 0.6. At -1, we are getting a discontinuous curve then. At -1, V0 will be 0.6. Okay. And the slope will be like this. What about the slope? Sorry, the slope will be negative. Negative slope means the curve will be like this. What about when V in is greater than -1? The output is minus 0.6. So this will be the graph. This is minus 0.6. So below minus 0.6 it is minus V in minus 0.4 and above -1 it is minus 0.6. So that will be the transfer characteristics of the circuit. Next problem. Assume that the OPAMP in the figure is ideal. We need to obtain an expression for V0 in terms of Vs, R and the reverse saturation current. Then we are given the value of R, Is and Vt. We need to find V0. And next it is asking if we replace the transistor by a PN junction diode, then what will happen? So let us go step by step. First of all, if we see that it is an inverting amplifier. Why it is an inverting amplifier? Because input is connected to the negative terminal. In that case, if Vs is greater than 0, V0 is less than 0. In inverting amplifier, the polarity of supply and output is opposite always. This is 0 and this voltage is negative. So this junction is forward bias. If it is forward bias, BJT will work in active region. In analog electronics, we don't operate BJT in saturation or cutoff. It works as an amplifier, so it will work in active region. Okay. Now let us see what will happen. If it is an active region, then we have the feedback path. If we have the feedback path, then we can apply the concept of virtual ground, right? If we can apply the concept of virtual ground, the voltage of negative terminal will be 0 because positive terminal is grounded. It will be 0 volt. So what will be this current I? I will be Vs minus 0 by R. That is Vs by R. Okay. So I will be Vs by R. Now this current I cannot enter the OPAMP. If it cannot enter the OPAMP, it will go here. This will be the current I. If you assume beta of transistor is high. If beta of transistor is high, IC will be approximately IE. So this current will also be I. Now we know ammeter current can be represented as Is e to the power VBE over eta VT. If eta is not given, consider it as 1. What is VBE? The base voltage is 0 and ammeter voltage is V0. So VBE is 0 minus V0, or you can say minus V0. So what I'll say now, I is Is e to the power minus V0 by Vt. What is this I? If you see here, I is Vs by R. So you can say e to the power minus V0 by Vt is Vs over Ris. So V0 is minus Vt log Vs over Ris, or you can say Vt log Ris by Vs. It is same as a log amplifier. Okay, but this time instead of diode we have used a BJT. In the next part it is asking us the value of V0. Vt is given as 25 millivolt, Is 1 picoampere, R 1 ohm. 25 millivolt, R is 1 ohm, 10 to the power minus 12, and Vs is how much? Vs is 1 volt. So 10 to the power minus 12 will come outside. Log of 10. Okay. So minus 25 into 12, how much will it become? Minus 300 log 10 millivolt. Okay. Log 10, how you can calculate? You can convert it to log on the base of 10. So it will be 2.303 log 10. So it will come out to be 2.303. So it will be 6.9, 690. So minus 0.69 volt. That will be the value of V0. Let us see the third case. If the transistor is replaced by a PN junction diode with reverse saturation current Is, with P side of diode connected to node A and N side connected to node B, like this, then it basically becomes a anti-log amplifier. So the relation will remain same. Okay, that is what I told you. This is the same relation, log amplifier. This is the same relation we studied in log amplifier, and it can also be obtained by the use of a diode instead of using a BJT. Okay, and that is what it is asking in the third part. Okay, so that is all from this video. In the next video, I'll show you more problems based on non-linear application. Okay, but what we have learned so far, if you apply open circuit test, then you can crack any problem containing diode and OPAMP. So that is the essence that you have to remember about this non-linear application. Thank you.
For 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2 year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these two channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel and not only subscribe, press the bell icon so that you get notified whenever a new video comes, and share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.